Good morning, afternoon, everyone. I'm Kumar. I've been working in Agentic AI systems and their security architectures for some time, and so I want to take some time and talk about that in this webinar. I've spent the last several years studying, building, and red teaming intelligent agents, some with Gen AI and then previously different kinds of automation and intelligence. And these agents that try and plan, reason, and act, often in unpredictable ways. So today we're diving into a topic that's moving from futuristic curiosity to operational urgency, the security implications of agentic artificial intelligence. Agentic artificial intelligence refers to a class of systems that can pursue goals independently, reason over time, store and recall memory, plan steps toward an objective, and interact with external tools such as databases, APIs, or even email systems. Think of LangChain, AutoGPT, Crew AI, Baby AGI, not just chatbots that respond, but goal-seeking agents that initiate actions, adapt, and execute. This transition marks a paradigm shift in how we build, deploy, and secure AI. And as someone deeply embedded in this space, I can tell you the security models we've relied on are no longer sufficient. So let's start with foundations of agentic AI. To truly defend against risks in agentic systems, we must first understand what they are. I often explain to technical and executive teams alike that agentic AI is not a fancy chatbot. It's a goal-directed, planning-capable digital actor. Let's break that down. So, autonomy. Unlike traditional models that respond only to prompts, agentic systems initiate actions on their own based on objectives and environmental state. Memory. These systems persist context and use historical data to inform future actions. I've seen memory mechanisms carry unintended data into sensitive tool chains, dangerous without strict control. Planning. They can break complex goals into sub-goals and strategize across multiple steps. Tool use. This is where the security stakes rise. Agentic AI doesn't just think, it acts. And that action may involve your cloud environment, APIs, or operational tools. So there are some technologies that are powering this shift, and they include things like LangChain, which is a set of tool chain, state handling, and agent orchestration capability. AutoGPT or Baby AGI, they are pioneers in autonomous task loops and goal decomposition. Crew AI, it's a multi-agent collaboration and hierarchical control. Model context protocols, MCP, a structured framework I've personally used to enforce temporal reasoning and boundary-aware planning. So why does this matter? Autonomy plus tools plus memory equals volatility. These systems evolve in flight, and when they do so without the right limits, we get unpredictable and often irreversible results. So let's talk about security risk categories. Over the last year, I've worked with several teams and advised multiple teams where well-intentioned agent deployments created vulnerabilities. Let's break down the main categories of risk that come with this type of work. First, you got misalignment risks. Agents may optimize objectives too literally. For example, a brand visibility agent starts auto-posting to every social platform without consent workflows. You could have tool misuse risks. I've seen agents use email, shell, and database access with no rate limiting. That's a massive risk. One startup's agent emailed internal debug logs to external users. You can have data leakage. It's very common when agents retain prompts, upload logs to memory, or misuse embeddings. For example, an agent could store sensitive tokens in persistent vector stores. Emergent behavior, especially in systems like Crew AI, collaborative loops can trigger novel behaviors that weren't explicitly programmed. For example, agents agreeing on a flawed heuristic and propagating it across task chains. You have new escalation vectors. With tool and system integration comes scope creep. For example, an agent used to manage tickets gains ability to deploy cloud instances via an API chain. Autonomous swarm attacks. This is where the frontier lies. Swarms of agents coordinating, learning from each other, and evolving adversarial strategies. I have simulated swarms where agents spread reconnaissance, payload generation, and lateral movement. Mitigation involves multi-layered governance. You need to have isolated planning states, encrypted inter-agent messaging, and a governor agent or a set of governor agents acting as ethical firewalls. As a practitioner, I view these risks as not just theoretical, but inevitable without discipline in design. Now let's move into the mitigation. So we'll talk about the security controls for agentic systems. These are the technical guardrails I advocate for in every production agent deployment. First, you want to start with sandboxing and execution limits. Deploy the agents in isolated environments with CPU, memory, time, and access constraints. Use containerization or serverless architectures with tightly scoped permissions. You have to treat agents like untrusted code because in many ways that's exactly what they are. You really don't know how they will behave when their environment changes. Number 2, output filtering and verification. Use downstream classifiers or policy-based models to catch harmful outputs before execution. So you filter for prompt leaks, command injections, and data misuse. In my own practice, this has caught hallucinated shell commands that would have wiped data directories. Key point is do not trust the output of one agent before you send it to another agent. Always look for problems and scrub it before you hand it off. Number 3, permission architecture. Enforce principle of least privilege on tool access. No agent should access tools it doesn't need. Build clear trust models, core planning agents, executor agents, and oversight agents with hard-coded boundaries. You have to treat it like you would treat a set of people that are definitely and always looking at each other's output, and someone is responsible for making sure that the quality and the security is always kept up front. Planning audit trails, log every plan, every action, every tool invocation. Use structured observability, timestamps, agent role, memory deltas, tool outputs. This isn't just for forensics, it's critical for interpretability and trust. Next, have human oversight. Insert approval steps for any high-risk action, email sends, API writes, or data deletions. You want to provide explainability interfaces. Why did the agent choose this? In every secure deployment I've worked on, human-in-the-loop checkpoints prevented major failures. Now let's talk about red teaming and threat modeling. Security isn't complete without pressure testing. So in my red teaming work, we simulate attacks that real-world adversaries might launch against agentic systems. So top tactics can include things like prompt injection, which is malicious user inputs that hijack goal-setting logic. State poisoning, you can have corrupting intermediate memory or logs to read out an agent's behavior. Tool abuse, getting an agent to misuse a trusted tool by exploiting insufficient validation or context-based understanding. So the frameworks that I rely on and that are very useful, meter attack for LLMs, it's still emerging, it's fairly new, but we're extending it with the agent-specific stages like planning, corruption, and tool exfiltration. Stride and Dread, they both can be adapted for goal-driven logic chains and memory threads, so are very useful. The key point is you want to treat your agent as both a product and an adversary. You're designed for resilience, not just functionality. Trust but verify. Let's talk about a few real-world case studies. These aren't hypotheticals. Let's walk through real incidents that I've seen either firsthand or verified through security partners. AutoGPT credential leak. This was an example of an agent scanning file contents. Without trying to, it emailed its own API keys to a testing address because the config file was too permissive and the prompt didn't filter secrets. So key point is filter secrets in any prompt, especially if the prompt is coming from, regardless of whether it's coming from a system or from a user, you want to make sure it doesn't contain any secrets. So you want to have a scrubbing step that detects secrets and removes them. Another example is of a shell execution failure. A React style agent interpreted vague user instructions too broadly, initiating shell commands that altered system paths. So key point, if you have an agent operating in an environment with access to a lot of power, a lot of capabilities, you want to put checks and balances to ensure that whatever you don't intend to be executed cannot be executed by that agent. Another example of a tool former misfire. A poorly validated agent sent incomplete but functional requests to an e-commerce checkout API, generating real purchase orders. Again, a lot of pain that the team had to go through to remove these orders, separate them out from the actual real purchase orders, and deal with all the ramifications. Another example is of a financial hallucination. An investment bot summarized real news with a hallucinated twist and posted it to portfolio dashboards used by day traders. Again, creating a lot of problem and a lot of mistrust in the system ultimately. Every incident taught us something. Containment, auditability, and human fallback aren't optional. You have to have them. So towards the end, let me leave you with this. Agentic AI is not a niche research domain. It's a new operational reality. We're not just building smarter chatbots. We're deploying autonomous systems that act, adapt, and collaborate. Their potential is massive, but only if we approach them with engineering discipline and cybersecurity rigor. Some resources I recommend for every practitioner: AutoGPT or agent simulations and security concerns. It's a foundational white paper on what happens when agents pursue goals unchecked. Microsoft's Threat Intelligence 2023, strong frameworks for modeling emergent AI risk. LangChain has security best practices, practical do's and don'ts when integrating memory and tool chains, and Anthropic's constitutional AI, an important perspective on value alignment through structured agent governance. Thank you for your attention today. My goal was to elevate the conversation and help you secure the frontier we're all now standing on. Let's see if there are any questions. Question 1. If agents can self-modify or change plans, how do we keep them from drifting into unsafe territory? Great question. My recommendation is to restrict planning loops with policy layers. So define hard boundaries for acceptable actions. You also want to add invariants to their logic, enforce goal scope memory, and always require justification before any escalation or tool switch. You want to add plan validation agents that can also act as internal governors. Next question, can you secure open source agents, or are we better off using closed internal ones? Open source agents can be secured, but only if you treat them like you would untrusted software. Vet every dependency, lock down tool access, strip memory persistence unless explicitly needed. I've hardened LangChain based agents successfully by inserting audit checkpoints and gating access by context conditions. The next question, what's the most overlooked risk in agent deployment today? In my view, emergent behavior in multi-agent coordination. When agents reflect, evaluate, or critique each other, you get feedback loops. This is powerful, but it's also the most common source of unintended behavior I see. So you want to simulate swarms before deployment, add supervisory scaffolds, never assume one agent's success generalizes across the swarm. You want to create swarms, you want to observe them, and use their behavior in a test environment to understand what scaffolding you need, what checkpoints you need, and what approvals you need to add. So in an unsupervised environment, the swarm doesn't go out of control. All right, I think that's about all the questions. If you have any other questions, definitely comment on the video and I will respond. And if you want to discuss any other related topics, do let me know. All right, thank you. Bye.